Right, looks like we have quite a few people joining, so I think we can probably get started. Thank you so much for joining us today for Beyond Compression, Safeguarding Your Data with Persistent Encryption. We have PKWARE CTO, Jason Dobbs, and PKWARE's Field CTO, EJ Pappas here to talk about all things encryption. We're gonna go, we can go to the next slide. We'll talk about the agenda. We're going to go through the common myths and realities of encryption needs today. We're going to talk about some of the recent breaches in MOVEit and Microsoft. We are going to go through a few customer use cases and new threats and solutions around AI and quantum, and then we'll end with a little bit of Q&A. But if you have any questions during the presentation, feel free to drop them into the chat, and we'll make sure the guys get them. So with that, EJ, I believe we will have you take it away.
Thank you, Sarah, and hello, everyone. I wanted to start by talking about the existing beliefs around encryption and the challenges that exist for the end user and the enterprise today. So when customers talk about protecting data today, they are traditionally talking about an outside-in approach. They are talking about providing EDR and XDR type of technologies, worrying about identifying malware and issues that are coming within your organization. What they're not talking about is data detection and response, or the concept of an inside-out type of data protection. So as we move forward and we talk about the breaches and the risks that exist within corporate organizations, nobody ever talks about people entering organizations or entering any type of corporate entity that comes on. They talk about the data that leads this organization. So in order to accomplish tasks around protecting data, encryption is the easiest way to protect your data. It is the most secure. It provides a limited amount of users the ability to interact with files. It's a known entity. You know who's going to open up those files. You know how they're going to open up those files, and you have a lot of security. So if that data is existing in the cloud, unstructured data that sits in Microsoft and in your cloud repositories, if the data exists on mainframes or in Google or in Azure or in AWS, in buckets or in structured data repositories that are there, you have an ability or an opportunity to be able to protect that data specifically. Now, in order to protect your data specifically, in order to protect your data in a rigorous manner, the first thing that you really need to be able to do is know what type of information that you have. You have to be able to discover the information. And so PKWARE fundamentally starts at the data layer and starts at that structured and unstructured component of identification. So we are going to find what is sensitive, what is proprietary, what is unique, what is important to you as an organization, and identify that for you. So our first ability is to be able to find the information wherever it happens to live: structured, unstructured, semi-structured data, cloud repositories, endpoints, file servers, mainframe. There is no location in your organization that PKWARE doesn't know where your data is and be able to report against that data. And reporting is the first step for providing a secure infrastructure and a secure manner of protecting that asset. But identification is merely the first step. If you are identifying data and then handing that off to some other product or some other process, then you're having the risk of having to re-identify or ensure that what I found is actually what I want to be able to protect. So what PKWARE can do secondarily is not only find the information, but fix it in a manner that you find unique or important to yourself within the organization. So fixing it means redacting information or masking information or encrypting information or moving information from one semi-safe location to a more secure spot that happens to exist in your organization. PKWARE has been around for almost 40 years. We fundamentally started our product, as you all know, based on compression, but we have moved from the very starting point to utilizing encryption. We started at 96-bit and 128-bit and 256-bit, and we use PGP keys and X509 keys and our own smart keys within the infrastructure. What we are providing organizations is the ability to identify who users are and protect it in a seamless manner. And we do all of those things because data doesn't sit at rest in any part of your environment. breaches occur, data is lost within corporate organizations and with enterprises because data isn't a standard or in a simple state of living in a spot. It moves around your organization. So we want to provide the protections to your data as it moves from user to user, from organization to organization internally, and sharing that information externally with your vendors, with your partners, with your customers. So if encryption is providing you protection and we can provide visibility to that data for you as an organization and for you as a user, I can see if my users have that data and I share it, I know where that data goes. Persistently, the data is protected inside, outside, and throughout the organization and throughout that whole workflow. So that was a lot of words, Sarah, but that's really the way that we start in terms of worrying about encryption. It has to be at the user level, it has to be at the organizational level, and we have to provide the flexibility to provide protection to that organization without requiring a key infrastructure or PKI to already exist, to leverage some other asset other than the identity of the users, the groups, and the data itself.
Right, and as EJ touched on, part of the secret sauce there is our ability to combine the encryption with the identity of the user. So you can rest assured that the person who is sending and the person receiving the information are the people that can in fact decrypt the information. And given everything that EJ just said, let's take a look at the next slide. Let's just take a look at some recent breaches that made headlines and how the data might have otherwise been protected in those situations. So, as the slide mentions, just keep in mind that the average cost of a data breach is approaching $10 million, according to IBM's cost of breach report. And that was last year, so it's probably over $10 million this year. And that's when you add up all the factors, including fines, lost time, additional work, and then the fallout from customers, investors, and the like. So first, I want to look at the MOVEit breach. And when you think about the MOVEit breach, it is unfortunate that in 2023, a SQL injection attack would still work. I feel like we were protecting against SQL injection back in the early 2000s when I spent my days writing code. However, let's talk about how a mature encryption solution would have made this breach essentially a non-event. From a compliance perspective, the MOVEit software checked all the boxes for securely sharing information with business partners. Files were encrypted in transit using TLS. They were encrypted at rest in the databases on the MOVEit servers, and then they were encrypted to the destination again with TLS. However, once the SQL injection attack occurred, the data was pulled out of the databases, and using those vulnerabilities, none of that encryption mattered. So how would this look different if an encryption solution was utilized? Well, if the files had been encrypted such that only the sender and receiver had the capability of decrypting that information, utilizing a true end-to-end encryption solution, then when the data was pulled out of the MOVEit database, it would have been useless to the attackers. When sharing sensitive information with business partners and third parties, there is a difference between checking that compliance box and truly encrypting the information end-to-end. Next, taking a look at Microsoft, they tried to pick a single breach, but there's so many over the last couple of years. But they really all kind of come down to stolen authentication tokens or a misconfiguration that exposed sensitive customer information. How the attackers actually get in is fairly irrelevant. The problem with Microsoft stems from the fact that businesses are trusting one company not only to provide the software, manage the data, manage the encryption, and manage the keys. Right? So not only can your users access keys to decrypt the sensitive information, but since Microsoft is holding your keys, their software, their systems can also decrypt your sensitive information as well. And that's how a lot of these attacks were successful. And this is how users can utilize web-based editors on their encrypted files in Microsoft 365. At PKWARE, we provide the software, but the customer holds all of the keys. We simplify that key management and we tie it to the identity for the end users to the point where the vast majority of them never even have to think about the keys themselves. But that end-to-end encryption being applied, and if it were applied in some of these attacks on Microsoft, any of those encrypted files that were compromised in the cloud, again, would be rendered useless to the attackers. The other logos that are on this slide all suffered similar compromises that would have resulted in less data leakage and damage if a solid encryption and key management solution had been applied.
I think, Jason, that You made excellent points in terms of the way that these breaches have occurred and the way that the customers could have changed their protection strategies. But I think that that's probably the real important theme that we need to remember is that PKWARE is a security company. We are a data protection company. We are focused on the data itself. We are focused on ensuring that the workflows that exist, the way that people interact with their data in their organizations today can be leveraged and still protected. So we don't want to change the way people do their jobs. We want to protect the way that they do their jobs. So when you were talking about the MOVEit example, or even in Microsoft, Microsoft makes their money by allowing users to collaborate and work successfully together across their infrastructure. They don't worry as much about protecting the asset because they have to worry about allowing users to be able to share collectively and work on documents in unison and be able to share that information internally and externally. We worry about protecting the data. So we can provide other mechanisms of protection, not just simple labels or productivity labels. We can provide things like redaction or masking or encryption and allow that encryption to flow through the workflow that they have and thereby protect the data that the customer has as it moves forward. So the burden falls in these workflows or in these examples, the burden falls on the end user to make sure that they're making good decisions. And in a PKWARE environment, we're going to ensure based on policy that the process that users are utilizing to share their data or work with their data are safe, secure, and well protected.
That's very well said.
So I think to kind of take that to the next level, I just want to talk a little bit about some of the ways that data gets protected within the workflows that we were talking about. So the first and simplest use case that we can cite when we talk about data protection is securing data in motion. And the industry sometimes confuses with protecting the pipe that the data is running on, encrypting that pipe or ensuring that the access to that pipe is secure as being data protection. There is a difference. The reason that there's a market called governance, risk, and compliance, GRC, there isn't an S in that acronym. So there isn't security as a part of that acronym. It's because compliance doesn't equate to security. Compliance equates to ensuring that certain rigor has been placed in surrounding your data or surrounding your policies. What PK wants to do is make sure that the data itself happens to be safe. So we've got customers who are sharing data, sharing high volumes of information, both inside of their organization and then externally to their partners. So what they need to be able to do is they need to be able to ingest information from external companies who are handling PCI type of information, PII and PCI information within their org, utilize that data, process it internally, and then send it off to clearinghouses and to other component organizations that they need to be able to ensure that there is accuracy with the data that they have and that there is integrity and assurance to the data that they are sharing. So in a use case that we have with a large financial institution, there's a number of them that we could kind of cite, but the first one that I would be talking about specifically is the ability to first ingest data, discover and identify what is unique, important, and sensitive within that, like credit cards, like personal identifiable information, and take action on that. So whether that is around redaction, whether that is around masking, or whether that's around encryption, to be able to ensure that the data is held in itself and then be able to share it externally. So I want to stop just for 1 second to say, when we talk about encryption and we talk about protection at PKWARE, encryption is a choice. It is one of the choices that we're able to handle for end users and for organizations and enterprises that work with us. The reason that we have been so successful in the regulated marketplace is that we do have choices, and we make each one of those choices handled equally as seamlessly as something like redaction, right? Redaction says I have a credit card, I'm going to remove the middle 6 of the credit card, and now I don't have to, that isn't sensitive any longer. But if you have to share that information with another organization and keep all of that information around it, I need to ensure that I can share that information with Jason or with Sarah and make sure that she receives it and only she can open up that information. So our workflow allows for that to happen. It allows for the sending organization to handle the keys, to understand who that user is, make sure that if that user changes from an engineering group to a marketing group to a finance group, that we can handle the differentiation of who gets access to that file, understand the wrapper or that identity piece of that, and then allow that information to be exchanged externally and then protected externally in case the data falls into somebody else's hands. The best thing about encryption is that if that data is ever exfiltrated and used by somebody who is not authorized, they don't get access to the data. They don't open up those files. They don't get to see what is important and what is vital and what is unique.
Next slide. Now that EJ's railed on privacy and compliance, I think I'll handle this use case. But in addition to sharing sensitive data, our customers have a need to complete and adhere to these compliance mandates and laws, whether it's GDPR, CCPA, PCI DSS, or new SEC guidelines, you name it. Discovery and encryption are key components to passing any and all audits, regardless of which one you're complying with. Our customers don't look at privacy and compliance as simply a checkbox. They go a step further than most and really do care about truly protecting the data covered by these compliance mandates. Many of our larger financial, insurance, and manufacturing customers use encryption as a way to comply with audit requirements regarding their PII, or personally identifiable information, along with credit cards and PCI data. In addition to encryption, they do utilize a lot of the things that EJ was talking about. They use discovery, they use redaction, they use our secure email capabilities and enhanced DLP capabilities to round out the data security posture. Some of our customers, prior to using our solutions, were in fact ransomwared, and they now use that encryption to protect their files on servers for HR data, finance data, in order to remain safe. Even if they're breached, as EJ mentioned, the encryption on those files renders those files useless to an attacker. One of our customers had a more challenging need in order to be proactive in ensuring that data is secured at its source, to adhere to some internal policies. They needed protection on a dozen or so Windows file servers, and according to policy, they needed to discover the PCI, PII, and social security data. From there, the data was redacted in order to remove the data from the files so that they could be used by anybody inside of the organization. Before removing any data, the customer made sure through our software that a copy of that file was made to a secure server where PKWARE encrypted those files. Then the only way that anybody could access the unredacted information in the original file was with the appropriate key. And as we've kind of mentioned throughout, that key management and that key distribution to the users is handled in an automated fashion on the back end.
Jason, I think since I was stepping on much of your last statement there, I'll just try to step one more time since I'm comfortable with it. I think that one of the best parts of the privacy and compliance story for us is that in many organizations, when you talk about data protections or you talk about protecting the data within an organization, you are talking to a specific part of the organization. You're talking to your security team, you're talking to your endpoint team or to your cloud team or some specific part of the organization. Many of our privacy and compliance groups that use our product are chief privacy officers or chief risk officers that have put policies in place and put our tools in place so that they're allowing us to be able to work within the framework of their data sets, which means that you don't have to worry so much about having competing products fighting for the same type of protections and thereby making the workflow and the work more complex for your end users and thereby increasing the risk of users not doing the right thing or having to make decisions about doing the right thing. For us, we want to fit into the workflows that they have. We want to build policies that are ubiquitous across users and groups and teams and allow that information to be able to flow and be protected. So our best credit is that you don't find our customers in the headlines. You find their ability to just be productive, or they don't find us in the headlines for data breaches. They find us in the headlines for being productive and being better at the jobs that they're supposed to be able to do. So on the next slide, in the spirit of not only working with the security team, one of our customers utilizes a particular, Jason was talking about CCPA and GDPR and the New York 500 requirements that exist, which are very, very kind of specific towards handling data in either financial services or in healthcare kind of related activities. We have other organizations that are just worrying about sharing data internally across the board. So if there is a particular requirement that exists within a particular frame of mechanism. So in manufacturing, for example, there is a TSAX, a TISAX standard that exists, 220, 221. I'm sure we come up with the right vernacular on that. But that requires data to be shared, but to be identified, classified, categorized, and then protected when it gets shared. So there's an edict to make sure that as the data is exchanged between large manufacturers, their subsidiaries, their parts developers, and their business partners, they have to make sure that that data flows in a particular manner and is held with a particular standard of rigor. So PKWARE can fit into a workflow that doesn't include encryption, that includes merely identification, reporting, and classification of that. And as that standard has evolved and increases the level of complexity or the level of rigor, adding things like encryption, it becomes just another choice for these users to be able to take that data, share that data, and then be a part of the same business flow. We don't have to add different products to this. We don't have to change the way that they are currently classifying and currently discovering data. They merely add an additional remediation so as to ensure or provide greater visibility and greater assurance and protections.
I knew one of us would remember DFS 500 at some point. So
sometime. Well, again, lots of letters and words. I didn't want to get all of them myself.
All right. If we look at the next slide, because it's 2024, Sarah made me have a slide that mentions AI, because it feels like every software company on the planet right now is AI washing their products and services. But this is an encryption webinar, so the elephant in the room isn't AI; it's actually quantum. There's a real and current and present threat, even though quantum computers aren't quite there yet to being able to crack existing encryption methods, in what is known as a harvest now, decrypt later attack. Hackers are grabbing encrypted data now, and they're going to sit on it until new opportunities with quantum computers exist to break those encryption algorithms. It really comes down to your sensitive data and how long that data would be of value to potential thieves. If your data has a relatively short shelf life in terms of value, a couple of years maybe, then you probably don't really have to worry about quantum right now or what algorithm, as long as you're using modern algorithms, how your data is actually being encrypted. However, if the shelf life is longer than that, the time is now to start looking at software that can utilize quantum resistant algorithms for encryption. So the current leading algorithms that have been selected by NIST are Kyber for asymmetric encryption and dilithium for digital signature applications. At PKWARE, we look for every opportunity to introduce these newer algorithms into our products while remaining nimble and remaining compliant with NIST and other standards in case new algorithmic compromises are found. So one of the things that you really need to look for today in an encryption solution is the ability to automate re-encryption of data that has already been encrypted using some quantum susceptible algorithms. That ability to be able to find, decrypt, and re-encrypt in an automated fashion is going to save people a lot of time and money.
Yeah, and Jason, you were so spot on in terms of hitting the real point here, is that AI is a checkbox today. AI is a buzzword. AI is 1998 companies saying that they are going to the web. They are going to go move forward and make their applications more web friendly. Everybody wants to talk about utilizing artificial intelligence in their applications. The component of artificial intelligence means that we can make things like discovery smarter, or we can make things like threat detection more nimble. And those are all true, and those are all valuable assets to the organization. But the bottom line is, when it comes to protecting your data, the only way to protect that data is through the support of quantum and our ability to integrate that into the natural workflows of our encryption algorithms, and then the way that we apply encryption to the tenets and foundation of our product set. So getting ahead of the game, skipping towards the end of the book, reading the last chapter, if you will, of solving the quantum problem and being able to be supportive of that quantum answer is the best way for you and organizations, the people on this call, to be able to stay ahead of the pack and stay secure and protected within their environment.
Thanks, guys. We do actually have a few questions in the chat, so I'm really glad we have our technicians on the line here. You mentioned end-to-end encryption. How does that differ from encryption methods on the mainframe, like IBM's pervasive encryption?
Jason, want me to go? And then
Yeah,
you can correct me.
I'll layer in on top.
And then layer in or change my view. So pervasive encryption is a wonderful, secure method of protecting data at rest. It is protecting the data at a block level, if you will, at a storage level, so that the data that has been written to disk is set in a manner that nobody can steal the DASD, steal the disk, and worry about that information being unencrypted or being read by users who don't have access to that data. So it's a good step in terms of protecting your information. The challenge that exists is, number one, there usually isn't visibility to what type of data that happens to be. So if that data is in a structured format, there are a number of vendors that have an ability to read structured data on mainframes. There are few, certainly one that is on this call, that can do discovery of unstructured mainframe data. So PKWARE has an ability to do that discovery. And then most importantly, we have an ability to encrypt that data as it moves from its location, from its resting location, to other parts of the organization or externally. So what PKWARE believes is that if you are encrypting the data itself and then letting that data live either at rest or keep it protected in motion, or as it is being exchanged outside of the organization, you're providing greater sense of protection. And it's truly end-to-end or user-to-user or destination-to-destination versus just worrying about transport being protected, disk being protected, and another location being protected. That still introduces risk within an end-to-end model, if you will.
Right. Yeah, I agree, EJ. I mean, I think pervasive encryption is great for data that's traveling within the IBM ecosystem. So when you talk about mainframe to hybrid cloud, you've got protection there. It's the minute that data leaves that ecosystem where you really need that end-to-end solution, whether you're sharing with distributed systems inside of your organization or sharing with business partners outside of the organization.
Great. So we had one other question, Jason. This is probably geared towards you. What steps should we be taking today to prepare for the pending quantum computing shifts that you're seeing?
Yeah, that is a great question. In terms of today, vendors right now, while they can, are introducing the newer quantum resistant algorithms into their software. I mean, Google's been doing it. Apple actually has it inside of their ecosystem as well. I think really what you need to do is make sure that your vendor does have a quantum roadmap, right? You don't want to be using a lot of these older algorithms too far into the future, right? And again, I think the biggest challenge that a lot of organizations are going to face with this is this problem of re-encryption, because if you kind of ignore data that's already been encrypted, that is still susceptible to attack, even if moving forward you're starting to use some of the newer algorithms. So I think having that opportunity to find all of your encrypted information and then re-encrypt it using the newer algorithms is pretty important.
EJ, anything to add? You good?
As much as I would like to continue talking and augment what Jason said, I think he's spot on.
Good. All right. So the last question, and keep adding them if you have any more, but how can I balance the need for encryption with performance consideration, especially in high traffic environments or applications that require real-time data processing?
Yeah, I mean, I think that's actually a really good question. When we look at real-time applications, that source. So, I mean, when you consider something like a mainframe, right? Obviously, that data that's hitting the mainframe is going to be protected in some way, or at least you should make sure that it's protected in some way. In that particular case, pervasive encryption would be an excellent choice. But really, the challenge comes when you start to move the data from that environment. So, you don't necessarily want to inject the overhead of additional encryption at that time of the transaction happening. It's really after the fact when you're taking the data out of that data store, moving it somewhere else. And as EJ mentioned earlier, part of that whole equation is you really need to understand where that sensitive information lies within your data set. So, we're not spending a lot of time talking about it, but really that discovery component and kind of mapping out where in your data estate those hotspots are to consider some automated encryption as it's moving throughout the environment. That's where the importance comes in.
I was going to say, Sarah, the one other piece that I think is really important in that story is flexibility. And so if you understand your workflows that you have within the data sets, a vendor like PKWARE, for example, has an API. We have products that run natively on the mainframe, that run natively within cloud repositories, that run natively on endpoints and on file servers. We have, application level integration. We have API level, SDK level integrations, and we have an ability to both go vertical and horizontal in the intelligent data processors that we have that can interact with the data that you have within the organization. So we need to I would suggest that the way that you safeguard against the challenges that you got with the question that you just posed is by best understanding what the workflow looks like, and then applying the encryption at the optimum level. So you apply either before it's going to leave that organization, so that you've got heavy processor on one side of one side of that coin, or at the point of being delivered to an endpoint or to another organization where you may have processor or flow, or you integrate that into the actual transport of itself using the APIs to ensure that the data is more seamlessly integrated and protected in that way.
All right. Thanks, guys. So if there are no other questions, we will give you guys some time back. As always, you can reach out to us on pkware.com or reach out to any of us individually. Have a great day. Thanks.
Thanks for coming.
Thanks.